Hi everyone, welcome to the Chapter 15 lecture for water quality. So we'll talk about global water challenge, water issues. I'm going to skip the hydrologic cycle in this lecture. You should read through the section in your textbook, but I assume you all understand what the water cycle is. Human influence on the hydrologic cycle, what kinds of water usage, and kinds and sources of water pollution, and water use planning issues. So the global water challenge. Global freshwater resources are threatened by rising demands. Growing populations need ever more water for drinking, hygiene, sanitation, food production, and industry. Climate change is expected to contribute to more droughts, and policymakers must figure out how to supply water without degrading the natural ecosystems that provide it. Water quality is as important as quantity. So 70% of the Earth's surface is covered by water in the form of oceans, which represents 97% of all the water on Earth. And of Earth's 3% of water that happens to be fresh water, only a tiny fraction is actually available for use. Potable water is unpolluted fresh water that's suitable for drinking. Shortages can be directly attributed to human-induced water pollution. And the image in the background here is the Ganges River in India. And you can see there's a lot of just stuff floating in the water. People come here to bathe and do laundry and get their drinking water. It's also really important culturally. The World Health Organization estimates 10% of the world's population does not have access to safe drinking water. And according to the UN Environment Program, between 5 and 10 million deaths occur each year from water-related diseases, including cholera, malaria, dengue fever, and dysentery. These illnesses have been increasing over the past decade, and without economic investments in safe drinking water supplies, the rate of increase will continue. Here's a map of areas of the world experiencing water stress. So if you look, the cooler the colors, the more water is available. And as you move into warmer colors, the more scarce it becomes. So looks like most of the world's water scarcity issues are in Asia, Europe, and Africa. Northern latitudes don't seem to be as affected. Or southern latitudes, I should include them also. Human influences on the hydrologic cycle. So runoff and the infiltration rate are greatly influenced by human activity. A major concern in many urban areas is transportation of stormwater. Water withdrawals are measurements of the amount of water taken from a source, and water incorporated into a product, like agricultural products, or lost to the environment through evaporation or evapotranspiration, can't be reused in the same geographic area and is said to be consumed. Right? So like if you buy a watermelon that was grown in California, you're getting water that was from California as well with that watermelon, right? And that's water that can't be used by Californians anymore because now it's in Michigan. Kinds of water use. Fresh water and conservation of aquatic resources are key to human well-being. The quality and quantity of water and life-supporting ecosystem services are being jeopardized by population growth, rural to urban migration, rising wealth and resource consumption, and climate change. If trends continue, 1.8 billion people will have water scarcity by 2025, and 2/3 of the world's population could suffer water stress. So here you can see people lined up to get potable water to carry home, and these are all the containers they're going to carry them home with. Domestic use of water. So over 90% of water used for domestic purposes in North America is supplied by municipal water systems, so like city water. The average person in a North American home uses about 400 liters or 100 gallons of water a day. 69% is used as a solvent to carry waste. So think of like bathing water, water for your washing machine, your toilets, washing dishes. 29% is used for lawn and garden, and 2% are used for drinking and cooking. Here's another way of looking at a similar data set. This is for a North American family of 4. And this one has the 2% of water for drinking and cooking, 6% for dishes, 29% for toilet flushing, 23% for bathing, 11% for laundry, and 29% for lawns. Something I think is interesting to look at here is that the EPA has put regulations on toilets. So toilets now are much more water efficient than toilets that were being manufactured 25 years ago. And laundry, most of us use washers and dryers to do our laundry. And most newer major appliances are also more energy and water conserving appliances. So hopefully as technology improves, the laundry and the toileting part and the dishwashing part become smaller. Bathing is something that can be managed also. We can get like low flow shower heads and take shorter showers. And then also lawn care here. So look at this, almost a third of water use in North American families is to water a lawn that gives us basically nothing back, right? So there are definitely places where we could sort of trim the water budget and conserve more water. Natural processes can't cope with highly concentrated urban waste. It has to be treated before release. A 2011 study found more than 200 unregulated chemicals, such as industrial solvents, weed killers, refrigerants, and a rocket fuel component percolate in the drinking water of 45 states. Public attitude is a major cause of water loss, and as long as water is considered limitless and expensive, there will be few conservation measures taken by the average person. So in 2015, the number of U.S. states reporting water stress was 46. Fast-growing Western cities are especially vulnerable. Shortages of water and increasing purification costs have raised the price of domestic water in many parts of the world, and increased costs do tend to reduce use. Many cities in China are setting quotas on the water use that are enforced by higher prices for larger users. Domestic water use. So at the federal level, the U.S. EPA is in the process of developing a national consumer label program of water-efficient products modeled after its highly successful Energy Star program. In addition to encouraging the public to conserve water, municipalities need to pay attention to losses that occur within the distribution system itself. Leaking water pipes and mains account for significant losses of water. Even in the developed world, those losses could be as high as 20%. And poorer countries may lose over 50% of their water to leaks. Those are shocking numbers. In North America, groundwater accounts for about 43% of the water used in agriculture, and surface water accounts for about 57%. Irrigation is the major consumptive use of water in most parts of the world, and it accounts for about 80% of all water consumed in North America. There are 4 common irrigation methods. Surface or flood irrigation is popular in places where evaporation happens quickly. It requires extensive canal systems. And that's what's pictured here. Spraying requires the use of pumps, and this is the kind of irrigation you'd see in Michigan, right? Those giant sprinklers that move around the field. Trickle irrigation is strategically placed openings that deliver water directly to the roots of plants. So if you've ever heard of like drip irrigation, it's kind of like a garden hose with holes poked in it. So it just kind of trickles water down by the roots of plants. So it's also another one that reduces loss to evaporation. And sub-irrigation. Underground pipes supply water to plants and can also be used for drainage as well. The costs for irrigation water have traditionally been low since many dams and canals were built with federal assistance. Competition for scarce water resources is prompting communities to raise water rates for irrigation, prompting farmers to conserve. Demand for irrigation water can also be reduced by reducing the quantity of water-demanding crops grown in dry areas. Industrial use of water. So industrial water use accounts for nearly half of all the water withdrawal in the US and 75% in Canada and 23% worldwide. 90% of the water being used for industry is for cooling, and it's returned back to the source. So very little of the water is actually consumed. Most processes involve a heat exchange. So that water is used to dissipate and transport waste as well, resulting in stream and lake degradation. The Clean Water Act of 1972 seeks to protect U.S. waters from pollution, and it specifically regulates pollutant discharges into navigable waters by implementing two concepts. The first is setting water quality standards for the surface water, and the second is limiting effluent discharges into the water. An effluent is like something that's dumped or allowed to enter surface water streams on purpose. It's intentional. All right, in-stream use of water. These uses are non-consumptive, so they're not using up the water. And major in-stream uses are hydroelectric power, recreation, and navigation. Presently, hydroelectric power plants produce about 6% of all the electricity in the U.S. Although hydroelectric dams control flooding and create electricity, they do have some drawbacks. There's high construction costs, habitat destruction above and below the dam. The dams reduce the scouring effects of flooding. They slow stream flow and silt deposition, and impounded water has an elevated evaporation rate. This is an image showing the effect of organic waste on dissolved oxygen. Specifically limits on BOD, or biological oxygen demand. So when there are few organics in the water, usually oxygen levels are higher. So here at the top, where the water in the stream is blue, there are 8 parts per million of oxygen dissolved in the water. So there's plenty of oxygen for fish and other organisms that live in this river to use, right, for cell respiration. Places with high biological oxygen demand, a zone of mixing. So this is a place where there's a lot of sewage, right? So here's a big city. They're dumping a lot of organic material into this river that needs to decompose. And as that decomposition occurs, it consumes the oxygen. That's why it has a high BOD. And when that oxygen is used up, not much else can live there, right? Just anaerobic organisms that often produce super nasty smelling gases. And then you can see as the stream moves on and that decomposing material is kind of diluted and replaced or refreshed with fresh water coming from upstream, the BOD goes down And we see the oxygen concentrations begin to creep back up the further we get from this dead zone here. So dissolved organic matter is a significant water pollution problem because it decays in the water. Biochemical oxygen demand, or BOD, is the amount of oxygen required to decay a certain amount of organic material. And if too much organic matter is added, all the available oxygen will be used up. And anaerobic bacteria begin to break down waste, producing a foul odor. Disease-causing organisms are a very important pollution problem in most of the world. Untreated or inadequately treated human or even animal waste is often the source of these organisms. And in the developed world, sewage treatment and drinking water treatment plants greatly reduce this public health problem. All right, nutrients can also be a problem. Eutrophication is a process where an excessive growth of algae and aquatic plants happens as a result of nutrient input. Particulate matter can also affect quality. And particles alter the clarity of the water. They cover spawning sites. They act as abrasives that can injure organisms, and they carry toxic chemicals. So if you've ever seen, usually I'd see it in a pond or something, often near a golf course or an agricultural field where they would apply a lot of fertilizer. A lot of that fertilizer will run off of where it was intended to be used and end up in a water source. And that causes the algae in the plants to just bloom and take over. And they can actually make the environment inhospitable, deadly for other organisms. So eutrophication is a real problem. There I go too. All right. Kinds and sources of water pollution. A point source is a source of pollution that can be located and identified, like a company or a city that was discharging waste from pipes right into a river, right? You can point to the pipe, you can follow the pipe back to the source, and you can know exactly where it's from. That's a point source pollution. Non-point sources are more difficult to identify and control. They're diffuse pollutants from agricultural land and urban paved surfaces. They come from non-point sources. An example of this is acid rain. So what I'd like you to do is pause this video for a moment and write a different example for each for a point source of pollution and a non-point source. Okay, individuals can protect surface and groundwaters from non-point pollution. We can choose to use less toxic or non-toxic alternatives to commonly used home chemicals. We can buy chemicals only in the amount that we actually need and apply them only as directed. More is not better. We can take unwanted household chemicals to hazardous waste collection centers. Don't pour them down the drain. And I wanted to show you this super quick little news clip about dead Lake Erie and the burning Cuyahoga River. Let's see if this works. Why not? All right, well, I guess I'll just post the link for you to watch. But do watch that brief video. All right, waste from homes consists primarily of organic matter from garbage, food prep, cleaning of clothes and dishes, and human waste. Fecal coliform bacteria is a generic term for bacteria found in the intestines of mammals. things like E. coli and Streptococcus faecalis. Numbers and types of bacteria present in water are directly related to the amount of fecal matter entering the system. This would be like if a beach is closed because of high E. coli counts. By January 2011, over 2,000 Haitians had died from a cholera outbreak due to contaminated drinking water. And I think this is right around the time they got hit with that horrible hurricane. So what I'd like you to do is take a moment to pause and think about these fecal coliform bacteria. Is it these bacteria that are making people sick? Or are they just an indicator of fecal contamination that could pose a different health concern? So just so you know, there's one strain of E. coli that makes people sick, like the one from the Jack in the Box burgers, but most E. coli are non-pathogenic. They can be found, however, in the same places as the organisms that cause cholera, but these are much easier to find and culture in the lab. All right, agricultural water pollution. Agricultural activities are the primary cause of water pollution. Excessive fertilizer use may lead to eutrophication in aquatic habitats. Runoff from animal feedlot carries nutrients, organic matter, and bacteria, and that runoff from large open expanses is a major source of water pollution, but it can be controlled. So we can leave a conservation buffer, which would be like the picture A on the left here. If you leave even, I think, as small of a buffer, as narrow of a buffer, it's like 3 meters of cattails, are really effective at pulling out a lot of the nutrients that are working their way down towards the river, like when it rains. And they also help stave off organic matter and bacteria. So there's some really good natural ways we can do this by preserving that buffer zone. And the buffer zone also, if you compare the image on the right with the one on the left, which has more connected habitat? Good. Yeah, the one on the left. So buffer zones to prevent water pollution can also double as travel corridors to improve connectivity among populations that live there of wildlife. All right, so leaving conservation buffers are really good ideas. We can also keep soil covered with a crop, right? So when a farmer is done with their cash crop or whatever their real goal is for production, they can cover crop their fields to help prevent soil erosion. And controlling the amount and timing of fertilizer application can also be a big improvement here. All right, marine oil pollution. Marine pollution has many sources, including accidents like the Deepwater Horizon and the Exxon Valdez. The Exxon Valdez, I know you know a lot about Deepwater Horizon, so the Exxon Valdez spilled 42 million liters or 11 million gallons of oil. It affected nearly 930 miles of coastline, and the economic impact on the local economy was severe. Tanker accidents are spectacular, but more oil is actually released as a result of small, regular releases from other sources. So 2/3 of all human-caused marine oil comes from street runoff, improper disposal of lubricating oil, intentional oil discharges during tanker loading and unloading. An international agreement was reached in 1992 that declared all new oil tankers must be double-hulled. And today, most tankers are. Only double-hulled tankers are allowed in U.S. waters. Let's talk briefly about groundwater pollution. Major sources of groundwater pollution include agricultural products like pesticides, And these things can leak from underground storage tanks. Landfills are another major source of groundwater pollution. So approximately 90% of North American landfills have no liners to stop leakage. And 96% have no collection systems in place to gather that leachate as it seeps from the landfill. So if you look at this picture, it's a modern landfill design. So you have a place where you store the refuse, right? Where you add more trash to the landfill here. And then eventually it will be sealed up with clay and vegetation. There's gas collection wells to help with the decomposition. And then there's also collection trays down here to gather the leachate liquid that would run from, top to bottom and be able to enter groundwater sources. So this is a good design, but most landfills in North America are not built this way. Groundwater pollution can also come from septic tanks. There are over 20 million septic tanks in the US, but about 1/3 are not working properly. And surface impoundments. Surface impoundments, if you don't know what they are usually earthen structures that are designed to keep in liquid waste. So 71% of these surface impoundments are unlined. Only 1% use a plastic or other synthetic non-soil liner. 99% of impoundments have no leak detection system. And 73% have no restriction on the waste that's placed in the impoundment. All right, and here's a nice little graphic of, different sources of groundwater contamination. We can see oil wells. Here's a waste lagoon from a farm, maybe. Coal strip mine runoff, accidental spills, de-icing salts, leakage from a landfill, leaking sewer pipes, leaking septic tank. Here's somebody's water well, pesticides on the farm. There's all kinds of things here, but this is a nice little graphic that puts it all in one place for you. All right, historically, wastes were discharged into waterways with little regard for the cost imposed on other users by the resulting decline in water quality. The population has grown dramatically, and thus domestic water use has intensified. There has not been enough water to satisfy everyone's needs. So think about this. Michigan is situated right in the middle of the Great Lakes. We have excellent clean aquifers underground, and many of us in Michigan do use well water for our drinking water in our homes. So in a future where water will become increasingly scarce, what would be some prudent measures for Michigan and other Great Lakes states to take now? So I want you to just think about this for a few minutes, pause the video, and jot down your thoughts. Try and come up with at least 3 things that Michigan could do now to secure our future with kind of being stewards of this incredible freshwater resource. Okay? All right. Metropolitan areas must deal with and provide 3 basic services. They need to supply water for human and industrial needs, and they need to have a wastewater collection and treatment. Urban areas are paved, and thus little water can be absorbed into the ground. So managing stormwater is also a problem. And the Water Quality Act of 1987 requires that municipalities obtain permits for discharges of stormwater runoff so that non-point pollution sources are controlled. Many cities have separated storm sewers from sanitary sewers to avoid contamination in a time of flooding or heavy stormwater runoff. But there will be other issues that have to be addressed in the future. Increased demand will generate pressure to divert water to high-use areas. There will be increased demand for wastewater treatment and reuse of existing water supplies. Salt backup due to evaporation may lower water quality, and groundwater overpumping will cause water tables to be lowered. When water tables are lowered, that allows for an intrusion of seawater into coastal aquifers, and that could ruin underground water supplies there. There will be increased demand for water-based recreation, which also demands high water quality. Water diversion is the process of transferring water from one area to another, and it's seen as a necessity in many parts of the world. One major consequence of diverting water for irrigation and other purposes is that bodies downstream are deprived of their water source. And this can have serious ecological effects. Lake levels decline, can affect fish and other wildlife populations. And a really good example of water diversion is the Rio Grande River. The Rio Grande has been diverted a lot in the U.S. for agricultural purposes. But as a result, in some places, at certain times of the year, the Rio Grande runs dry. And that means that farms downstream who had previously been able to depend on that water don't have it. Wastewater treatment. Oops. Looks like I skipped primary sewage treatment. Well, primary sewage treatment is when basically solids are filtered out from sewage so that we have solids in one place and liquids in another. Secondary sewage treatment is a biological process that follows primary treatment. Such facilities are designed to promote bacterial and other microbe growth, which will degrade the organic matter. Wastewater is mixed with large quantities of highly oxygenated water to encourage this growth. And in a trickling filter system, wastewater sprayed over a surface of rock or other substrate to increase the amount of dissolved oxygen. Sewage sludge is a mixture of organisms and other particulate matter that have settled out during the treatment process. Activated sludge sewage treatment plants hold wastewater in settling tanks with air continuously bubbled through it. The water and sludge eventually separate out. You can see on the left here's primary wastewater treatment, and on the right is secondary. Tertiary treatment is an additional stage used to remove inorganic components like phosphorus and nitrogen left after primary and secondary treatments. This process is extremely costly because it requires specific chemical treatment of the water. Some municipalities use natural or constructed wetlands to serve this stage, and some areas use effluent to irrigate golf courses, roadside vegetation, or even cropland. And the vegetation takes up the nutrients and prevents them from being released into streams and lakes. Groundwater mining is removing water from an aquifer faster than it can be replenished. Extended periods of mining can lead to land settling, lowering of the water table, and saltwater intrusion into wells near coastal areas. I included a picture of a Nestle water bottle here. Nestle is one of the companies that pumps groundwater to bottle and then distribute and sell nationwide. An average of 85 billion gallons of groundwater are withdrawn daily in the U.S. 90% of this water is used for irrigation, public supply to home, businesses, and industry. Irrigation accounts for 2/3 of the water, and groundwater provides about half the drinking water in the U.S. Rural areas especially depend on groundwater for drinking. Water sustainability is a trade-off between groundwater use and long-term effects of that use. Management strategies include a shift from groundwater to surface water and importing water from outside of local water system boundaries. Control pumping with guidelines, policies, taxes, or regulations. Conservation practices, techniques, and technologies. Reuse wastewater like gray water. This would be like water from your washing machine. And treated wastewater, reclaimed water for non-potable purposes. Desalination of brackish groundwater. All right, preserving scenic water areas and wildlife habitats. Some bodies of water have unique scenic value. The United States Federal Wild and Scenic Rivers Act of 1968 established a system to protect wild and scenic rivers from development. All federal agencies must consider the wild, scenic, and recreational values of certain rivers when planning and the development of rivers and adjacent land. So I'd like you to pause the video, think about a scenic waterway that you would want to see preserved. What's something that you would miss if it were gone or developed or polluted? All right, wetland conservation. So causes of wetland loss from 1986 to 2010. The major culprit has been urban development and rural development. Forestry and agriculture. Water use planning issues. So historically, poorly drained areas were considered worthless, and they were filled in or drained and used as building sites. Less than half the original wetland acreage remains. And in the U.S., 95% of the remaining 50 million acres of wetland are inland freshwater wetlands. Even the United States Capitol building was built on a wetland. Only recently has the natural and economic importance of wetlands been recognized. Wetlands provide wildlife spawning and breeding habitats. They're natural water filtration systems. They slow floodwaters, permitting nutrient settling, and they also help to control floodwaters. All right, more on the value of wetlands. They filter toxic waste, excess nutrients, sediments, and other pollution. They help prevent erosion, and they reduce flooding by storing stormwater. They reduce storm damage by absorbing waves, and they provide feeding and resting spots for migratory waterfowl. They provide food and habitat for other aquatic species, and they provide nursery sites for the young of a number of different species, including oysters, clams, crabs, and shrimp. All right, so in summary, water is a renewable resource that circulates continually between the atmosphere and Earth's surface. The energy for the water cycle is provided by the sun, and there are two basic kinds of aquifers. An unconfined one, receiving water from the top, and a confined aquifer, between two impervious layers and under pressure. The way in which land is used has a significant impact on the rates of evaporation, runoff, and infiltration. The four human uses of water are domestic, agricultural, in-stream, and industrial. Water use is measured by either the amount withdrawn or the amount consumed. And domestic water is in short supply in many metro areas. The largest consumptive water use is for agricultural irrigation. And major sources of water pollution are municipal sewage, industrial waste, and agricultural runoff. Organic matter in the water requires oxygen for its decomposition and therefore has a large biochemical oxygen demand, BOD. Point sources of pollution are easy to identify and resolve. Non-point sources of pollution are more difficult to detect and control. Thermal pollution occurs when an industry returns heated water to its source. Temporary changes in water can alter the kinds and numbers of different plants and animals that live in it. Wastewater treatment consists of primary treatment, a physical settling process, secondary treatment, a biological degradation of the waste, and tertiary treatment, chemical treatment to remove certain components. Groundwater pollution comes from a variety of sources, and reduced water quality can seriously threaten land use and in-place water use. All right, as always, please write down any questions that you have, bring them to student office hours or to class with you.